not problems. Okay. Now, what we'll do is I'll give you a list of formulae, which is like all that you need for this chapter's board exams. All that you need. First, we'll take the basic equation, like the Einstein's equations. Okay. Even before that, I'll give you the equation for stopping potential. So your maximum kinetic energy, Kmax, equal to E into Vs, where E is what? Charge on an electron. Vs is stopping potential. Kmax is maximum kinetic energy of the electron. Equation 1. Followed by that, we have the same equation Kmax, or the same term Kmax in another equation, equals h nu minus phi or E minus phi or h nu minus h nu naught or hc by lambda minus hc by lambda naught. Same thing, same thing, same thing. Same formula. Okay. Here I can write either Kmax or E into Vs, because as you can see, both are same, right? E into Vs, or this is a very bad E into Vs, I'll write like proper E into Vs, I'll write E into Vs. Now, this is the thing that you need to remember here. Basically, all you need. If you are asked to find momentum, that this, then you need de Broglie wavelength and all. We'll go to that part now. De Broglie wavelength, momentum, that this, what you find. If an electron is accelerated through a potential of V volts, some volt V, then you have lambda, wavelength of the electron, equals 1.227 by root V, what? Nanometer. Now, if you do not know the value of V, instead you know the value of energy of the electron, kinetic energy, then we have K equals P square by 2m. K stands for kinetic energy, P for momentum, M for mass of an electron. Okay. Moving on. If you simply know the velocity and not kinetic energy, you don't need to go through this. You can simply take lambda equals h by p. Cannot see h by p. Okay. What is h by p? What is p? Momentum. H by mv. This would be all you need. Would be. Okay. Basically, what you need. This would be enough. This is the like your cheat sheet of formulas. You didn't take one sheet to your exam, which you don't. This is all you need for this chapter. You can play around with this and get some answers. All right. I'll erase all this if need be, because I have to write a numerical now. Big enough. We'll continue. We'll start. How many numericals have you done? 1, 2, 3, 4, 5, 6, 10. I don't know. How many?
2, sir.
2, sir. Correct. But continue from the third one. And you will tell me step by step answers. Okay. I'll give you the formula. You will calculate. You will tell me the answer. I don't know the answers. Like I don't have them here. You see my screen. All right. Now, here we'll start with the third one. The photoelectric cutoff voltage. Cutoff voltage means stopping potential. Same thing. Cutoff voltage, stopping potential. Vs is given. In a certain experiment is 1.5 volts. Cutoff voltage or stopping potential. Okay. What is the maximum kinetic energy of photoelectrons emitted? The first formula that I wrote. What is given? The given value is Vs, cutoff voltage, stopping potential, same thing, equals how much? 1.5 volts. Question. What is the maximum kinetic energy of photoelectrons? Kmax equals question mark. Now, point to be noted. If you are asked the same question in competitive exams, you directly write 1.5 electron volt is your answer. Same figure. 1.5, 1.5. Volt, stopping potential, electron volt, maximum kinetic energy. This is not your competitive exam. You have to go through like board stuff. So write the formula. Write Kmax equals E into Vs. What is Vs? Given here. What is E? Charge on an electron. What is the charge? Magnitude. not minus sign. What is charge of an electron?
1.6 into 10 to the power minus 19 coulomb.
Correct. Yeah. Put that value here. 1.6 into 10 power minus 19 into what is Vs? 1.5. Please tell me the answer. Quick. Don't watch here. Like this might be wrong. Might be right, might be wrong. I don't know. I don't want that answer. Calculate and tell me the answer.
2.4 into 10 to the power minus 19.
Into 10 power minus 19 unit.
So
Now, this is the value. I get it. Correct. Okay. I want a specific answer. This one in electron volt. If I ask the question, give me the answer in electron volt. What will you do? What will you do? You will do a very simple thing. There are two methods. Okay. One, you divide this by the value of electron volt or charge on electron 1.6 into 10 power minus 19. You'll get the same answer. Where is it? Same thing you'll get. Another method. You will take Kmax in joule equals E into Vs in joule. Convert this to electron volt. What happens? You multiply the value of E. Correct? Kmax into E. Okay. Into looks weird. So I'll just write it in bracket. Into E. This becomes electron volt. Equals is the unit, by the way. We'll have E into Vs. You cancel these things. This also becomes the value of Kmax in electron volt. Like you can't have it. That is the answer that you get. If you are finding the value in electron volt, this is the value 1.5. Same thing. Okay. Now, if I ask you the value of electron volt, you don't take the same value. We know stopping potential equal to maximum kinetic energy in electron volt. Therefore, this is the answer. Take the question is your answer. No, you don't do it. You take it and you calculate this part. You tell me what you get. Cancel 10 power minus 19, 10 power minus 19. You'll have 2.4 by 1.6. Answer. Same thing, sir. Same thing. Correct now. This what is 2.4? 1.6 into 1.5. This thing cancel. This will be remaining 1.5. Same answer will get. Any doubts here? I raise it because you have to do this on your own. Okay. Should be able to do this on your own. It should not be a problem. We'll go to the next one. A little bit bigger we'll take. Question number 4. The threshold frequency for a certain metal is 3.3 into 10 power 14 hertz. Minimum frequency required for photoelectron emission is this value. So we'll write this at nu naught. What is our value? Nu naught equals how much? 3.3 into 10 power 14 hertz SI unit. Fine. Now, if light of frequency so and so is incident on the metal, is the incident frequency. This is nu light frequency equals. Oh, I'm sorry, not this value. We'll take 8.2 into 10 power 14 hertz. Question. Predict the cutoff voltage for the photoelectric emission. Vs equals question mark. At what reverse voltage will the current stop? Now you take the equation, the earlier one, that is, you don't write Kmax. Instead of Kmax, like you have Kmax equals E into Vs, right? Maximum kinetic energy equals charge of electron into stopping potential. So write E into Vs directly. E into Vs. This is the formula. Equals h nu minus h nu naught. Now why this specific formula? I have nu and nu naught. H is a constant. E is a constant. This is what I want. All the terms are known factors. put the value, get the answer. Be done with it. Okay. You will have Vs equals. I'll take H common here. H, I'll take E to denominator of here. This will go here. Okay. H by E I'll get into nu minus nu naught. Makes sense? This is my way of calculation, because I don't want to multiply H into nu once, H into nu naught once, then divide by E. I'll just do H by E. Nu into nu naught is like some factor, because the power is same, 10 power 14, 10 power 14. I can easily do minus 8.2 minus 3.3 to get some answer. Multiply by H, divided by E. Makes sense. I don't want to multiply twice. Only once is enough. Can anyone tell me the step-by-step answer here? I'll continue with this. I'll have Vs, stopping potential, equals. What is the value of H? Can anyone tell me the value of Planck's constant, please?
6.63 into 10 to the power minus 34 joule second.
Joule?
Per second.
Joule second, not joule per second. Okay. To 10 power minus 34, your value is right. Joule second, I'll not write the unit. Into, what is the given frequency? 8.2 into 10 power 14, right? 8.2 into 10 raised to 14 plus 14 minus threshold frequency 3.3 into 10 power minus 14. Great. Divided by, what is the charge of an electron? E value. Correct. Now, as the powers are same, please do 8.2 minus 3.3. What is the value?
4.8.
Minus this. What's the value?
4.8.
No. Is it right? It should not be right.
4.9.
4.9, sir.
Because you have 2 minus 3, you'll get 9. You'll get 9. It is 8.2 minus 3.4.9. Okay. That's 9. If you don't mute yourself, you're out of the class. Right? Yeah, right. For a second. Divya, before you're getting scoldings or brothers getting scoldings, something is happening, be sure you are muting yourself when you're not speaking. This is going to YouTube. This will look real nice. Anyway, I want 8.2 minus 3.3, which is like 4.9. 4.9 into 6.63. Answer, please. These two values, okay, minus into this value, 6.63. 4.9 multiplied by 6.63. Any value?
32.48.
32.48. Divided by 1.6. Divided by 1.6. 32.48.
20.30.
I didn't hear the last part. 20.3.
304.
3. Okay, 3 is fine. 20.3 into, now here I have 10 power plus 14 into 10 power minus 34. What will I get? 10 power minus 20 is what I'll get. Divided by, my 1.6 is gone. It's already here. 10 power minus 19 I have. Okay. So our value is, this goes up, this becomes 10 power minus 1. Minus 20 plus 19 will become. Okay. So we will have 20.3 into 10 power minus 1. What's the unit of potential? Volt equals 2.03 volt you'll get. 2.03. Okay. How much will you get? 2.03 volt. Answer. Clear? Easy, simple. No problem here. Pretty clear.
Yes.
Sure?
Yes, sir.
Patka?
Yes,
Can I
sir.
erase this? Okay. That's clear. I'll erase this part. We'll move on to the next one and I'll clean my PDF. I'm going to save it. Next one. Question number 5. The work function of a certain metal is 4.2 electron volt. They're directly given 5 value. Oh, this is, I'm sorry, too small. There is 1 second. 5 value work function equal to how much? 4.2 electron volt. Will the metal give photoelectric emission for incident radiation of wavelength 330 nanometer? The radiation that is coming in has a wavelength, not frequency, wavelength of 330 nanometer. Now, condition is very simple. If your wavelength is less than threshold wavelength, photoelectric emission. If your wavelength is equal to threshold wavelength, still okay, photoelectric emission. If your wavelength, incoming wavelength, is greater than threshold wavelength, no photoelectric emission. You just have to see, like you have phi here, and phi equals h into nu naught, also equal to h into c by lambda naught. You do only one thing. You calculate lambda naught. Check if lambda naught is greater, equal or less than lambda. Check what is the case. Someone find the value of lambda naught, that's all. Your value for lambda naught equals what? Hc by phi. Please convert the value of phi into joules. The current value is in electron volt multiplied by 1.6 into 10 power minus 19. You will get in joules. Take that value, calculate Hc by phi, tell me the value. Or if you want, we'll do together. Your choice. Together? Or you'll do? Will you do it yourself or some answer please from your side? No answer. Not tell sir.
Will do, sir.
You will do. Great. You tell me the value of lambda. Lambda not, I'm very sorry, lambda not. In nanometers you tell me, because the given value is in nanometers, right? 330 nanometer. Tell me the value in nanometer. Anyone? Someone take a calculator, please. Anyone has a calculator in their hand? No one? You say yes, sir.
0.0.
0.0?
843.
No. No. That is pretty low value. Into 10 per watt. Thing to know. Please multiply this phi value into the value of E. 1.6 into 10 per minus 19. Otherwise, you will lose your SI unit. You will not get the value of lambda, which is supposed to be an SI unit. Lambda naught equals the value of H. I'll take as 6.63 into 10 power minus 34. Okay, into the value of C, 3 into 10 power 8 meter per second, divided by the value of phi, which is 4.2, into the value of E, that is 1.6 into 10 power minus 19. Now, if I raise a calculator, which I will, because you are not having the answers, raise a calculator.
That's 0.029
10 per watt.
minus 9 meter.
0.02. A chance here, I have done some mistake. Some mistake you have done. We'll see. Please tell me step by step, or I'll tell the values we check. Okay. Our value should be.
Sir, 10 to the power minus 7. Sir.
That would work. That might work. Into 3 equals so and so. Divided by 4.2 equals so and so. Divided by 1.6. Value is 2.959. Correct. Now 10 powers or scientific notations. This is 34 plus 8. What is minus 34 plus 8? Minus 26. Right. Now this comes to numerator. You will have minus 26 plus 19. What's the value?
Minus 7.
Plus
Minus
Seven.
7.
7.
So the value should be this value 2.96 I'll take. It's 2.9598, right? Minus 2.96 I'll take. Here value. I'll take lambda naught equals 2.96 into 10 power minus 7. What's the unit of lambda? Meter. Now continuing on. I'll just shift these 2 points to RHS. So this value rises by 2. 10 power minus 9 it will become. I'll have lambda naught equals 296. If that is 10 power minus 9 meter, what do I call it? Nanometer. This is the maximum wavelength. Above this, there is no photo emission. Question, the given value is how much? 330 nanometer, which is greater than the lambda naught. Will there be photo emission? Question, will there be photo emission? Yes or no is the answer.
No, sir.
No, because I just told you, if the given value of lambda is greater than, I wrote ulta. No, I wrote properly. Yes, correct. Given value is greater than lambda naught. There is no photo emission. Given value is 330 nanometer. Our maximum value is 296. There is no photo emission. So you'll write the answer as the incident wavelength is less than, greater than threshold wavelength. There is no photoelectric emission from the metal. Simple. Okay. Okay. Here is this.
Yes, sir.
Now to the next part. Which is over. Light of frequency 7.21 into 10 power 14 hertz. That's the given frequency. I'll write straight away. What is the given frequency? Nu equals 7.21 into 10 power 14 hertz. Is incident on a metal surface, right? Electrons with a maximum speed, okay, is given Vmax. What is given? Vmax, not potential, not this, not kinetic energy, potential, Vmax. Maximum speed of 6.0 into 10 power 5 meter per second. 6.0 into 10 power 5 meter per second are ejected from the metal surface. Fine. What is the threshold frequency of photo emission of electrons? Is asking for mu naught equals question mark. Simple, very simple. You take the equation, instead of k, write half mv square. What do you write? Half mv max square actually. Mv max square. Because Vmax is like given, m is a known value. Okay, half is like half. Equals h nu minus h nu naught. Why this? Because nu is a given value, right? H is known value. Nu naught is the question. You have to find it. You know all the terms. Find it. So what will you do? You will shift h nu to this side and this one to that side. So that this becomes plus. Or even before doing it. I'll take h common. I'll do what? Take h common because I want equation for mu naught. I can essentially calculate and then take the terms. That's also fine, but I like it better if I have the terms in order first and then substitute. Okay, so I'll take h common here. I will get the same thing, half m v max square equals h into mu minus mu naught. Makes sense? All right. Going on. If I take this, then I want mu naught. I'll send h to LHS. Okay. So I'll have half or 1 by 2h m v max square equals mu minus mu naught. This goes to LHS. This comes to RHS. Now it happens. So we have mu naught required value equals, that's the required value, right? Or am I doing everything wrong? Okay, that's sequence, fine. Mu naught equals mu given value minus mv max square divided by 2h. Find the value. You know the value of mu, m value, v value, h value. Find it. Or I'll even write the values. You calculate. That will be much easier. Okay. So the values go like this. What is the value of mu given value? 7.21, right? Correct. It is 7.21 into 10 power 14 hertz minus. Now we have a lot of terms. I'll just open a bracket just to be safe. Mass of electron. Anyone? M is mass of electron.
9.1 into 10 power minus 31 kg.
30.
1 kg.
Correct. I'll make this like clear. Okay, 31 proper 3 will make 31 kg. Okay, fine. After this, we have into V max square. What is the maximum velocity is given? This square it says V max square into what is 6 square? 36 into what is 10 power 5 square? 10 power 10. That is V max square straight away. Divided by 2. Okay, I'll just write the 2 to left side. 2 into 10 power, I'm sorry, 2h, right? 6.63 into 10 power minus 34. So someone do me a favor, calculate 9.1 into 36 divided by 2 divided by 6.63.
24.70.
Okay. Now we'll come to 24.70 as it is. If it is right, 24.70. Okay. Now I have 10 power minus 31 plus 10. That's 10 power minus 21. Right? My 10 power minus 34 goes up. I will have 34 minus 21. What's the value? 10 power plus 34 minus 21 is what I'll have. What is the value of this?
30.
13.
So here what I have is 14. I'll need to make this 14 as well. So I'll move the point over. This becomes 14. Simple things. So I'll have 2.47 into 10 power 14. That's the value. This is minus. This is the whole bracket thing. Okay. Still the bracket thing. I have the original value as it is. 7.21 into 10 power minus 14. Now as the powers are same, you can just do 7.21 minus 2.47. That should be your like final value. What's the value? 7.21 minus 2.47.
4.74.
4.74. 74. Got it. I'll write 4 also. Wait. 4.74 will write. Into 10 power minus 14 is the answer, right? What is the unit of frequency?
Hertz.
Hertz. Hertz. So many hertz. That is our answer. Have you got the answer? 4.738, 4.74, same thing. All right. Is it clear? Now, I'm not saying that you have to do all the substitutions, take this to that side, create a formula for mu naught, then put the value. No, we can take this formula, put the value of m here, v here, h here, nu here, and h here. Do all things, do everything. Okay. Then take this to LHS. Take the minus into that side, it will become plus. So this will become plus, that will become minus. Okay. And then divide by h. Works. Also works. No problem. All right. You can substitute the value directly, then do everything. My preference is I will make a formula for the required term and then solve. That is only my personal preference. You can do anything you want. The formula should be right, answer should be right. Okay, it's not that you can do anything you want. No. Answer should be right, formula should be right. Clear? Any doubts here?
No, sir.
No, sir.
Shall I erase this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Big enough? No? Big enough. Okay. Now that question is over. We'll move to the next one. I want to finish all this, but I cannot finish all this. Okay, fine. Okay, 6th one is over. 7th one. Calculate the momentum and de Broglie wavelength of electrons accelerated through a potential difference of 56 volt. Question. Or given value, only one value. What is it given? V, accelerating potential, equals 56 volt. Question. You find momentum and de Broglie wavelength. There are multiple methods. I'll first find de Broglie wavelength because it's an electron. And my formula is like straightforward. I have lambda equals 1.227 by root V nanometer. Or I'll not write nanometer, I'll write 10 power into 10 power minus 9 meter. This is my direct formula. Put the value of V and tell me the answer. Root of 56 you do, tell me the answer very quickly.
Seven point four eight, sir.
How much?
7.48.
Into 10 power what?
1 minute, sir.
10 you'll get, I think.
So 0.1642.
This is 0.164.
Yes, sir.
So we have 1.227 divided by, what is the value? 4 volts, right?
7.4.
Okay, oh, correct. The value is 7.54. 54 volts. Sorry, 56 volts. I'm sorry. 1.227 divided by 56 root. 7.48, correct. The value is 7.48. Again, into 10 power minus 9 meter. That is your wavelength. Do we have the answer? 0.16 they have got. How so?
Sir, at 7.48, very 56. Yes.
How that? Only root 56.
Yes, sir.
That makes sense. ಯಾವನ ಮಾತಾಡೋದು ಫೋನಲ್ಲಿ ಅಲ್ಲಿ
ಏನ್ ಹೇಳು
ಪ್ರಜ್ವಲ್ ಕೂಡ
ಇಲ್ಲ
I'm joking. If you want to speak, you speak, man. Like after the class. Okay, so your value is 7.48, Allah. You have to do 1.227 by 7.48.
0.164.
Both answer comes. ಇದು one answer ಅಲ್ವನಾ equals
Yes, sir.
0.164
164
nanometer
into 10 power minus.
minus 9 meter. This is the value of wavelength of electron lambda. We are not done. Okay, this value we got. Great. Question and momentum also. We have to find what? Wavelength and momentum. This is like simple formula. Can you tell me the formula of de Broglie wavelength? De Broglie wavelength.
Wavelength is equal to h by p.
Yes, lambda equals h by p. What do we want? P. P equals h by lambda. Do it. P equals 6.63 into 10 power minus 34 divided by what is lambda? 0.164 into 10 power minus 9. Now you get the answer. Sixth answer. Let me point out the answer given here is incorrect. You see
Sir,
this answer.
40.4
40.42 into 10 power
4
25.
into 10 power minus 25.
40.4 into 10 power minus 25.
10 power minus
25.
25.
Unit. Forgot. It is momentum mass into velocity kg meter per second. ಅರ್ಥ ಬಿಡ್ತಾ ನೋಡಿ ಇಲ್ಲಿ ಬಂದಿರೋ ವ್ಯಾಲ್ಯೂ ಕರೆಕ್ಟ್ ಆಗಿದೆ. The given answer is what? 4.44 into 10.6. If you see the unit, what is the unit? Meter per second. Question ಕೇಳಿರೋದು momentum, ಕೊಟ್ಟಿರೋದು velocity or speed. That might be a right answer for speed. That is not the question, right? This is your answer. Lambda and p. Those are the answers. Proper. Okay, na? Very simple. ಕಷ್ಟ ಇದೆಯಾ?
No, sir.
Easy. You will say easy, sir. Easy. Alway. Excellent. Next one. The work function of cesium metal is 2. Okay, adalla. Oh, we have question number 8. I'm sorry. Question number 8 we have. What is momentum? 1. P. Okay. Speed 2. And de Broglie wavelength. Of an electron with kinetic energy 120 electron volt. So they have given K equals 120 electron volt. That is equal to 120 into 1.6 into 10 power minus 19 joule. And electron volt better because I want momentum and speed and wavelength, which are like SI units. I'll convert this into some value. In birthday 1.6 into like 120 in birthday
192, sir.
192. We will have also equal to 192 into 10 power minus 19 joule. This is the given energy, kinetic energy of electron. Now the question, number 1, momentum. Number 2, speed. Number 3, de Broglie wavelength. How do you approach this? Again, I want momentum, speed, and de Broglie wavelength. There are multiple formulas. We can take K equals P square by 2m. You see momentum, K you have m, you know. Bad answer. This is bad. Sorry. You want momentum or speed first. Okay, we'll take speed first. If you have that value, then like from kinetic energy, like K equals half mv square. Alva. You know the value of K and yeah, find out V. Then multiply it by mass. you'll find momentum. Then de Broglie wavelength h by p you do. You take this equation, okay, put the value of k, put the value of m, get the value of v square, take square root, you'll get m, sorry, you'll get v. Next step in Madra, you'll get the value of v, multiply m into v equals p. You get the value of momentum. So first step, speed is done, this formula. Second step, momentum is done. Third step, de Broglie wavelength, you take lambda equals h by p. P put the value in h by p, get the answer for lambda. It's also done. Okay? I'll not do it. You have to do it. If you are not comfortable, which you should be comfortable, okay? If you are not, then take this formula. Write p square equals k into 2m. P equals root half k into 2m, which is like in your derivation, same thing. You will have root of 2m ev, same thing. Okay? Here, you put the values of k, 2 is 2, m. You get the value of momentum. Divide momentum by mass, you will have the value of speed. Then take lambda equals h by p, get the value of wavelength. Either use this set or you use this set. Anything, okay, not this. This set or this set. Both are fine, like both will work. Okay? Anything is fine. You'll get the same answers. Wherever you start. Next one, this is your homework. Okay? I want to see these in your notebook in the next class. Next class, notebook I'll finish this thing. Okay, I'll finish this. We have 2 more numericals. I'll give you the hints and we'll go off. Right? Next, question number 9. Work function of cesium metal is 2.14 electron volt. Go to the value, but we'll write nevertheless. Value of phi. Value of what? Phi for cesium. I don't care. Equals 2.14 electron volt. Okay. A beam of light of frequency, incident frequency nu equals how much? 6 into 10 power 14 hertz. Is incident on the surface. Find number 1, energy of photon E equals question mark. It is simple. For this you use E equals h nu. Nu is a given value. Put the value, get the value of E. You need it anyway. Okay. Next, maximum kinetic energy. Same formula. You take K max. Only one formula equals E, that is h nu minus phi. Phi is given. E you will calculate. Put the values. You're over. Done. Okay. E is what? H nu. Phi is what? H nu naught. That's what I gave you the initial formula. K max equals h nu minus h nu naught. H nu is E, energy of photon. Okay. Write down the do it. These are the formulas. For next one also, this is the question number 9, alva. 9th question. For 10th question, I'll send this picture or send this board itself to you. This will be active for 1 day. The board with the formulas. Next one. The threshold frequency of certain metal is 3.3 into 10 power 14 hertz. Threshold frequency. So mu naught they are given equals how much? 3.3 into 10 power 14 hertz. Meaning below this there is no photoelectric effect. If light of frequency so and so is incident on the metal, calculate stopping potential. Okay. Your value of nu is how much? 8.2 into 10 power 14 hertz. Question. Stopping potential Vs equals question mark. Same thing you will take. Not instead of K max, you take what? E into Vs equals h nu minus h nu naught. Nu is no value. Nu naught is known value. Okay, h is known value. E is known value. Calculate Vs. Simple.
Yes, sir.
Very good. Any doubts in today's whole numerical things? Yes or no?
No,
Okay.
sir.
No? Okay. This is
No,
what
sir.
I will share you this board. Okay. Chat. This board will be with you. You can check out this board. Okay, you can log in. You have access to this board. That's the link that you have seen in the chat is the board. I leave this board as it is. Those are the formulas if you forget or anything. If you have not written, this will be active for only one day. I'll take it to tomorrow. Okay. I want to see all these numericals in your book in the next class. Okay. I will see you in next class, pa. All right. Sure.
Yes, sir.
Bye bye.
Sir.
Bye, sir. Thank you. Thank you.
Welcome. Bye.